So we're starting section 8.8, and we're actually doing 8.8 and 8.9 together. The title is Factoring Perfect Square Binomials and Trinomials. Okay. The warm-up question that we are about to do right now is factoring this quadratic trinomial ax or 9x squared minus 12x plus 4. And we should all know that step one is to multiply a times c. So everybody please follow along if you haven't done it already. A is 9 and c is 4. So when you go 9 times 4, you're going to get 36. Step 2 is to make a list of the multiples of 36. So how could I get 36? It's 1 times 36, 2 times 18, 3 times, and if you don't know your multiplication tables, you could get a calculator and do 36 divided by 2, it'll give you 18. Or 36 divided by 3, it'll give you 12. 36 divided by 4, it'll give you 9. 36 divided by 5 won't work. 36 divided by 6 is 6. So those are all the possible multiples. And what we need to do is find the pair of numbers that combines together to give us the middle value b, which in this case is negative 12. So if I were to add 1 plus 36, that'll give me 37. And that b value is not a 37, it's a negative 12. So that doesn't work. When you add 2 and 18, that's 20. That doesn't work. The middle term is not 20. 3 and 12 is 15. That's not 15. 6 and 6 is 12. But you want it to be a negative 12, not a positive 12. So you have the right number, just the wrong sign, which means we have the right numbers, just the wrong signs. So change both of those positive 6s to negative 6s. Then after that, what we do is jump to our factored form format of parenthesis, 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 parenthesis. And in the first part of my binomial, I'm going to put an ax. A is 9. And of course, we're dealing with x's, so you're going to put a 9x here and a 9x there. If you're using this shortcut method that I showed you most recently. The other method would be to change this binomial or this trinomial to a 4-term polynomial by replacing your middle term with those two negative 6s. So if you wanted to, you could say 9x squared minus 6x instead of the minus 12x, and then plus 4. That way you could factor by grouping because you have 4 terms. But the quicker, better method would be to jump into this factored form format with ax and ax. In this case, a is 9 with an x, so you have 9x and 9x. And over here on the blank spots, you put the pair of numbers from step 2, you just plop them right in there. So you're going to have a minus 6 right there and a minus 6 over there. And then after that, step 4 is to magically divide each binomial by the greatest value that you can, if you can. If you can't, you just rewrite it. But this first binomial, 9x and minus 6, you could divide both of those terms by 3. 9x divided by 3 is 3x. 6 divided by 3 is 2. Of course, you have a minus sign. And same thing with the other. You could divide both of them by 3 and get the same thing, 3x minus 2. And there is your factored form of this quadratic trinomial expression, right? And other books, they may rewrite this factored form. Since it's the identical binomial, 3x minus 2, identical 3x minus 2, they could choose to rewrite it as 3x minus 2 in parentheses squared, because that means the same thing as having the binomial 3x minus 2 times the binomial 3x minus 2. On the online quizzes assignments that I give, I'm going to want you to type it out like this with no spaces between your terms. Okay, so we should know how to do this. It's one of the more challenging ways of factoring. Today, I'm going to show you a shortcut that's going to be beneficial to actually doing this one right here. Okay, you don't have to copy this down, but please pay attention. When you have a quadratic trinomial, ax squared plus bx plus c, if the a and the c values are perfect squares, if you have a perfect square term in the front and a perfect square term in the back, then you simply square root your first term, square root your last term, and then plug it into your factored form answer format. That's what we're learning today. That's the meat and potatoes of today's lesson, all right? So check this out. Right here we have a 9x squared, and we have a 4. Are these perfect square terms? If you forgot what a perfect square term is, just remember a perfect square number or a perfect square term comes from simply squaring numbers. So like 1 squared is 1, that's a perfect square term. 2 times itself is 4, perfect square term. 3 times 3 is 9, 4 times 4, 5 times 5, 6 times 6. You could make a perfect square number list even if you don't have it memorized. You could create it by simply doing 1 times itself, 2 times itself, 3 times itself, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared. And we've done this in the past where if I take the square root of any of these perfect square numbers, it's a nice perfect answer. The square root of 64 is what? Wow, everybody's asleep, huh? Square root of 64 is what? 8. Square root of 25? 5. Square root of 100? 10. So we've already done this before. It's really easy to take the square root of one of these perfect square numbers. So now that we know, or now that we've remembered what a perfect square number is, now we could actually look for perfect square terms. If your A value is a perfect square term and your C value is a perfect square term, you could take the square root of them and plug it into your answer format. So I'm going to rewrite this question right here. Okay, here it is. 9x squared minus 12x plus 4. I notice that this guy right here is a perfect square term, and I notice that this guy right here is a perfect square term. So what these notes right here say is that I could square root those terms and plug it into my factored form answer format. Now, what answer format are we talking about? A binomial times a binomial. So when you think about 9x squared, what is the square root of 9x squared? Well, the square root of 9 is 3, and the square root of x squared is just the regular x. So the square root of 9x squared is 3x. And you would write that as the first term in each of those binomials. You just write it twice. And then you think, what is the square root of positive 4? 2. So you put that answer 2 right there and right there. And then all you got to do now is think about the signs that belong in here. Now, in order to find out the signs that belong in here, you got to look at this sign and this sign, okay? So at the very end, we have a positive 4, right? When you're distributing and then combining like terms, at the very end, when you distribute, in order for you to get this last number, positive 4, it's either going to be a positive 2 times a positive 2 or a negative 2 times a negative 2, because that's the only way when you distribute you're going to get a positive 4. So if you notice that the middle sign is negative, then obviously they can't be positive and positive, because then the whole thing would be positive. So they both must be a negative and a negative, okay? So you got to think about the signs that belong in there according to this last term and then according to this middle term, all right? And this is the way to do it. You square rooted it, you plugged it into your answer format, you thought about the signs, but you do have to double check it, all right? So let's double check. If I were to distribute, well, actually, I don't have to double check because we already did this exact problem, and we got 3x minus 2 times 3x minus 2, so we did it correctly. But whenever you do this and you don't have the actual answer to double check it, I want you to distribute, combine like terms, and see if it works out, right? So I want you to do this. 3x times 3x, 9x squared. 3x times negative 2, negative 6x. Negative 2 times 3x is another negative 6x. Negative 2 times negative 2 is positive 4. And as you can see, those middle terms, when you combine the negative 6x with the negative 6x, you will get that b value, negative 12, right? Negative 12x, that is, right? So I'm going to repeat that question right here for the video. You asked, what if one of them is not a perfect square number? So like if you had a 9x squared and then a 5 right here, then you can't do this, right? So this is just another tool in the factoring toolbox, right? When you have a perfect square term in the front and in the back, you could square root them and plug it into your answer format. But you still should double check because maybe that middle term doesn't work out, right? And as you can see, this is a lot faster than doing that multi-step process that we did at the beginning, right? So it's just another tool. You're not going to be able to use it all the time. As a matter of fact, you're rarely going to be able to use it. The only time you're able to use it is when you have a perfect square term in the front and a perfect square term in the back. And that's what we're focusing in on today's lesson. So I kind of made some notes for you guys. Maybe these are a little better to copy. So here's a note that says, if you have the quadratic trinomial ax squared plus bx plus c, and the first term is a perfect square and the last term is a perfect square, then what do? Well, you write your parentheses, you actually do the square root of that number, right? So if there's a 9 right here, the square root of 9 is 3, and you put it with an x because the square root of x squared is x. And if you had like a 25 over here, then you do the square root of that c value, and that'll be a 5, right? And of course it says think about the highlighted signs, right? So if your c value is positive over here, then they're both going to have to be positives or maybe both negatives depending on that middle sign. And of course, it might sound confusing right now, but the more you practice it, the easier it gets. Okay? And not only does it have to be a perfect square trinomial, where you have 3 terms, it may be a perfect square binomial. Same exact thing. If you have a perfect square term in the front and a perfect square term in the back, and there is no middle term, the bx term is gone, then you could still square root them and plug it into your answer format. The only difference is that the minus sign has to be there. If there is no minus sign, then you can't really do this. If there's a plus sign, then it's not factorable. I mean, with this method, that is. So we have both of those notes. I want to pause it and let you guys copy it down if you want. And in addition to copying it down, I would like you to copy down these practice problems right here. These are all obviously quadratic trinomials. These are all difference of 2 squares. Whoops, my bad. Technical difficulties. So what I'm going to do right now is focus in just on trinomials first, and then on difference of 2 squares, a perfect square binomials next. I mean, technically, the way the book breaks it down is they do difference of 2 squares as 8.8, section 8.8 in the book, and the perfect square quadratic trinomials are 8.9 in the book. So the book itself actually divides it into 2 sections. I'm doing both sections in one because it really is the same lesson, where if you have a perfect square term in the front, perfect square term in the back, you square root both of them and plug it into your answer format. Plug it into your answer format once you square root them. And then think about the signs. So when we take a look at this first one, now I know you're thinking, well, I don't need to think about these perfect square ones because this is the regular quadratic trinomial with the a value of 1. And how would we do that before? We would simply go parenthesis, parenthesis, x, x. Now, why would I do that before? And I still do it now because x times x is x squared. It's when I have a number out here that I need to do that long process of multiplying a times c, then thinking of the list of the multiples of that number. But when you don't have a number, it's really easy to set this up and think what times what is your c value that if you combine together is your b value. And you may have to make a list. What times what is 25? It's either 1 times 25 or 5 times 5. That's it, right? So which pair of numbers combines together to give you the middle value, negative 10? 5 and 5. But if I add 5 plus 5, that'll give me a positive 10, and I want a negative 10, which means I have the right numbers, just the wrong signs. So please change those signs to minus 5 and minus 5, and voila, that is your factored form, right? This is not the new method that I just showed you. Let's actually show you the new method, which is not a good idea to use in this case. So I'm going to erase that to make space. What I would do, if you wanted to use the first method, is to recognize that there is a perfect square term in the front and there is a perfect square term in the back, which means you may be able to do the parenthesis, 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 and then simply think what times what, not what times what is the square root of x squared? Square root of x squared is x. What is the square root of 25? Square root of 25 is 5. So you're going to put an x and a 5, an x and a 5, and then you got to think about your signs. What signs belong in here? Well, since it's a positive 25 at the very end, the signs have to be the same because that's the only way you're going to get a positive 25 when you multiply. It's either going to be a negative 5 times a negative 5 or a positive 5 times a positive 5. But looking at that middle term, being that it's negative, you know that it has to be both negative and negative. I hope that makes sense. So you'd have a minus sign and a minus sign, and as you could see, it's the same as the original method, same answer, that is, the same factored form answer. So to be honest with you, if I ever do have no number out here in the front, I'm not going to do square roots. I'm just going to think what times what is c that if I add together is b. Now down here, I do have a number, and I notice that they're both perfect square terms. So on this one, I'm going to jump to my factored form answer format. I'm going to do the square root of 9x squared because it's a perfect square term. What's the square root of 9x squared? 3 with an x. So put a 3x, put a 3x. And then the last term is a perfect square term, 4. So what's the square root of 4? 2. Put a 2 there, put a 2 there. And now think about the signs. What signs do you think belong in here? Positives, both. Because everything's positive, so you're going to put positives on both. It's impossible to have one positive and one negative. That wouldn't make sense because a positive 2 times a negative 2 is not going to make a positive 4 when you distribute, right? So when you see a positive C value, then they either both have to be positive or both have to be negative based on this B value that's positive. You know that both of them are going to be positive. Okay, oh yeah, by the way, we need to double check, right? Even though I kind of don't like quadratic trinomials because it's so easy to get those answers, but you should still take the time and double check. So if I were to double check, 3x times 3x, 9x squared, 3x times 2, 6x, 2 times 3x is another 6x, 2 times 2 is 4, and when you combine the 6x with the 6x, it will give you that B value of positive 12x. So I know I did it right. Here's my correct factored form. That's what you type in on quizzes with no spaces between your terms to get full credit. This one right here, I do have a perfect square term in the front. I do have a perfect square term at the back. So I am going to square root them and plug them into my answer format. So what are my binomials going to look like? What is the square root of 25x squared? 5 with an x, 5 with an x. And what is the square root of 36? 6. Now think about the signs right here. In order for us to get a positive 36 at the end, when I multiply this 6 times that 6, they're either both positive 6s or both negative 6s. What do you think? Both negative 6s is the best option. Because when you do multiply negative 6 times negative 6, it'll give you that positive 6, 36, and our middle term will end up being negative. However, I put this one here on purpose to emphasize how important it is to double check your factored form answer. Let's double check it and we will see that it does not work. It does not work. Check it out. 5x times 5x, 25x squared, that's good. But when I go 5x times negative 6, that's a negative 30x. And then when I go negative 6 times positive 5x, that's another negative 30x. And negative 6 times negative 6 is positive 36. So as you can see, the middle terms, negative 30x and negative 30x, that's negative 60x, definitely not that middle value, negative 11x. So this is wrong, okay? So even though I had a perfect square term in the front and a perfect square term in the back, even though I could square root them, my answer just doesn't work out. So this is not factorable. Or you could say prime, okay? I mean, technically you're supposed to multiply A times C, get a huge number. Think of the multiples of that huge number, see if that combined together to give you B, but it's not going to work. So yeah, it's prime. It doesn't work. How about this last one? We do have a perfect square term in the front. We do have a perfect square term at the back. So jumping right into our factored form answer format, what will it be? The square root of 64x squared, 8x, 8x. How about the square root of 1? 1 and 1. How about the signs? Both plus. And that's it. Cool? So I think we've done several examples of having a perfect square quadratic trinomial. Oh yeah, I forgot to double check it, and I say it's important to double check. So if I did double check, 8x times 8x is 64x squared. 8x times 1 is positive 8x. And then 1 times 8x is another positive 8x. And that's how we get that middle term of positive 16. So I checked it, right? And 1 times 1 is 1. So obviously it does work. So I did factor this correctly, okay? These are perfect square quadratic trinomials. And I personally would way rather have perfect square binomials, also known as difference of two squares. Now, why would I rather have these guys? Because you don't really need to double check. It's pretty simple. If you have a minus sign, then you could just square root them and plug them into your answer format. Square root them, plug them into your answer format. And because it's minus, they have to be different. It doesn't matter if it's plus or minus or plus. This is the format, and there's no real reason to double check it. So number one, right here, x squared minus 49, I would not even think of perfect square terms. But if I wanted to, I would say, okay, what is the square root of x squared? It's just x. What is the square root of 49? It's 7. And what signs belong in here if you want it to be a negative 49 at the very end? One has to be positive, one has to be negative, and it doesn't matter where you put the negative or the positive as long as the signs are different. Make sense? Now, like I said, I wouldn't have done the square root on this one. I would have just set up, since there's no number in the front, I would have done parentheses, x, x, And I would think, what times what is negative 49? That if I combine together as a middle value, which is nothing, oh, that'd be a positive 7 times negative 7. That gives you negative 49. And if you do combine it together, it gives you nothing, which means that there is no bx term, there is no middle value. Okay, how about this guy right here, 81x squared minus 16? See, we do have a perfect square term in the front, we do have a perfect square term in the back, and it is a difference of two squares. Because it's a difference of two squares, you know that one sign is going to be a plus sign in the middle, the other one's going to be a minus in the middle. But before we get there, what is the square root of 81x squared? 9x. What is the square root of 16? 4. And like I said, because there is no middle term, when you distribute, the middle terms have to cancel out, which means that one has to be positive, one has to be negative. And that makes total sense because that's the only way you're going to end up with a negative 16 at the very end, a negative 4 times a positive 4, or positive 4 times negative 4. I mean, you don't have to double check it, but let me just verify. 9x times 9x, 81x squared. 9x times negative 4 is negative 36x. But when you do positive 4 times positive 9x, that's a positive 36x. And those 36x's, the positive and the negative, they will eliminate when you combine like terms. At the very end, we got the positive 4 times negative 4, it's negative 16. So these guys do cancel out, and it does check off. It is the original. So this is the correct factored form. Now, what about this next one? 36x squared plus 25. Even though there are perfect square terms in the front and a perfect square term in the back, you cannot set this up. This is actually not factorable, right? This is not factorable. Or you could say prime. Prime. Why is that? Because it must be a difference of two squares in order for you to be able to apply it. There is no way, I mean, think about it. We have a positive 25 at the very end. Even if you were to think about square rooting, all right, the square root of 36x squared is 6x. But the square root of 25 is 5. And when you actually think about the signs, the only way to get a positive 25 is if you have a positive 5 and a positive 5, or a negative 5 and a negative 5. But having the same signs, positives, or same signs, negatives, will not have the middle term cancel out like it did above. The only way the middle terms cancel out is if they're exact opposites, which means that one has to be plus, one has to be minus. I apologize for the waste of time. This did not work. We call that prime, or you could say not factorable, NF, right? Last one here. The square root of, I mean, these are perfect square terms. We have a perfect square term right there. We have a perfect square term right there. So let's plug it into our answer format by square rooting. So what is the square root of 121x squared? 11x. What's the square root of 1? 1. So you put 11x and 1. 11x and 1. And the signs, they have to be what? A minus and a plus, or a plus and a minus. Doesn't really matter. That's it. Cool? That is the lesson today. However, just like all lessons, we factor to be able to, when we have an equation, to be able to split them and solve using zero product property. So for example, if this had an equal 0, then I'd have an equal 0 here, then I would take these and split them and set them each equal to 0, right? That's what I write down right here. And you don't have to copy this down, but you could just pay attention. It says, factoring is great to get multiplication when solving an equation, to be able to apply the zero product property. But if there's only 1x squared, then you can isolate it and apply a square root. But when you apply a square root when solving, you must put a plus or minus on your answer. Okay, before I even go through these two examples, let me just do a side note over here. You see, if I told you, hey, there's a certain number squared and my answer is 9, what are the values? What are the answers that work? What number squared is 9?
3.
Yeah, it could be x equals 3, but it could also be x equals negative 3, right? If you plug in a negative 3 right here in parentheses, negative 3 times itself, it'll give you a positive 9, right? So we actually have two answers for this one equation. Another way of writing these two answers is to just write it x equals plus or minus 3. That's the notation that represents two answers, a positive 3 and also a negative 3. Okay. Another thing that I asked you, or that I mentioned right now on the notes, is that you could apply a square root when there's one single x. So like solving, back when we said solving in semester 1 of algebra, how would we do that? We would say, I want to get x by itself on one side. Is x by itself? No, it's not by itself. There's a 2 right there, a power of 2. So if you wanted to get rid of that power of 2, you could do the opposite of the power of 2. And the opposite of the power of 2 is a square root. Okay, a square root undoes a square. Kind of like a plus 2 undoes a minus 2, or a times 5 undoes a divided by 5. Right here, a square root undoes a square. And when you do to one side, do to the other, you will get x by itself. The equal sign will come down. But the detail that you need to learn today is that when you apply a square root in an equation, you have to put a plus or minus in front of your answer. The square root of 9 is 3, but you have to put a plus or minus in front of your answer. Okay, so I apologize for this huge lesson, but this is important. Let's jump back over here to our notes. We have two equations. Let's look at this bottom equation first. You see, when I try to solve, I want to get x by itself, but the problem is that you don't have a single x. You actually have two types of x's. You have a regular x and you have an x squared. So you can't get x by itself on one side. So from there, what we think is, well, let's move everything to one side to get it equal to 0. I'm going to move that minus 4 over. And I can't really add 4 with 12x or negative 12x. So I'm just going to rewrite the whole thing. It's going to say 9x squared minus 12x plus 4 equals 0. And now I have an equation that's set equal to 0. And if I'm able to factor right here and set it as a binomial times a binomial, then I could split them and set them each equal to 0 using zero product property. So recognizing that there's a perfect square term in the front and a perfect square term in the back, you will be able to factor using square roots. The square root of 9x squared is what? 3x. How about the square root of 4? What's that? 2. So you put a 2 right here and a 2 right there. And what about the signs? Well, I do need to end up with a positive 4 when I multiply, but when I combine like terms, I need a negative. So what are my signs going to be? Okay, if I put a negative and a positive at the very end, negative 2 times positive 2 is not going to be a positive 4. So they either have to be both negative or both positives. Does that make sense? So what do you think they're going to be? If they're both positives, then everything's going to be positive. That doesn't make sense. So yeah, you're going to put both negatives. So that's the correct factored form. If you double check it, you'll see that it does work. And this is equal to 0. Okay. Now the other option would be to do the long process of a times c. That'd be 36. You make a list of multiples of 36 that combine together to give you b. And then you could plug it into your factored form answer format. Then you could divide by whatever possible. And you'll get to this same factored form anyway. Okay. Anyhow, now that it's factored, you split it and solve. You're going to have a 3x minus 2, set that equal to 0. 3x minus 2, same equation, set it equal to 0. So you're going to get the same answer. So you only have to solve one of them. You're going to go plus 2 plus 2. You're going to have 3x equals 2. Final step, divide by 3. Divide by 3. That'll be 2/3. So the answer is x equals 2/3. And if you did the same for this one, you'd get the same answer, x equals 2/3. It'd be ridiculous to write the same answer twice. So just write it once and you're good to go. Now, any questions on that? Taking a look at this one, it is a difference of 2 squares, so I could apply a square root on both of them. However, you could also just isolate the x because there's only one x. It's not like there's an x squared and then another x over here. There's only one x right here. You could actually isolate it. You could get x by itself on one side. Let me actually rewrite this over here so I could show you that. X squared minus 49 equals 0. I'm going to isolate the x by adding 49. Adding 49, I'll end up with x squared equaling 49. I could get rid of the square by applying the inverse operation of a square, the opposite of a square, which is a square root. And when you do to one side, you do to the other side. Now, the square root of x squared, the square root and the square eliminate themselves. That's like saying a plus 2 and a minus 2. Those guys cancel out. Right here, the square root and the square cancel out. They eliminate themselves. You're going to end up with x equals, and we know that the square root of 49 is 7. However, when you apply a square root in an equation, you must put a plus or minus in front of your answer. So that's actually two answers, x equals a positive 7 and x equals a negative 7, right? We solved this by applying a square root to get rid of a square. We could not do that down here because there's more than one x. What other way could we have solved this? You could have factored right here, recognizing that it is a difference of two perfect square terms, or you could even factor the original way, saying, well, x and x times x will give me an x squared, and then you could think, what times what is my c value of negative 49, that if I combine together is my b value, which is nothing because there is no middle term, there is no bx term. So when you think what times what is negative 49, that combines together to give you nothing, that will be a negative 7 and a positive 7. And if you were to split those guys, x minus 7 equals 0, x plus 7 equals 0, then you're going to get your two answers, x equals positive 7 and x equals negative 7, which is the same thing as over here, just different notation. The plus or minus really does mean positive 7 and negative 7. And those are your answers. Okay, man, crazy long. Now, I do have a worksheet for you guys to practice. So you have a two-sided worksheet. On one side, you have the 8.8, which is really the difference of two squares. It's only two terms. Perfect square term in the front, perfect square term in the back. Square root both of them. Put a plus or minus on each of the binomials. 1 plus, 1 minus. Or you have 8.9, which is the perfect square trinomials, right? So how about this? Let's look at a couple of them. So like right here, it's as easy as this. Number 7, parenthesis, the square root of 121m squared. What is that? That's 11m. So you put 11m as the beginning of both binomials. And then the square root of 144p squared. That's 12 with a p. 12p. 12p. And of course, the signs have to be different, 1 plus, 1 minus. There's your answer, right? Now, it does get a little weird at times. Like, check out number 12 right here. Those are not perfect. Well, they are perfect square terms, but even before doing the square roots, the first type of factoring that you ever learned was what? First type of factoring. Even before grouping. 3 letters. GCF. So if there's something in common, pull out that thing that's in common. So as you can see on number 12, the 36z to the third and the minus 9z, there's something in common that you could pull out. For sure, you could pull out a z, but there's something more. There's actually a numeric value you could pull out, both of 36 and 9. And what is that greatest value that you could pull out? Because of GCF, greatest common factor. What could you factor out of there? Could you factor out a 3? Yes. But is there something greater? Yes. You could factor out a 9. So 9z is the GCF. If you pull out a 9z, what would be left on the inside? A 4z squared minus 1. Are you with me? And if you look at that inside binomial, it is a difference of two perfect square terms, which means that you're going to be able to factor it further using the shortcut. Take the square root of that. What's the square root of 4z squared? 2 with the z. 2 with the z. And then what is the square root of 1? The square root of 1 is 1. And of course, what signs need to be in there? 1 negative, 1 positive. Because there is no middle term. A negative 1 times a positive 1 is the only way to get a negative 1. The signs have to be different. Doesn't matter if it's positive first or negative first, but as long as they're different, that's the way it works. Now that 9z, that GCF that you pulled out originally, you're going to have to bring that down as well. And you're going to have to type this whole thing to get full credit. 9z, open parenthesis, 2z minus 1, 2z plus 1. Okay? So it may be a bit weird on this worksheet. Pull out the GCF. Always try to pull out the GCF first before continuing factoring. Pull out the GCF, and if you do have a perfect square term, then obviously square root and plug it into your factor form answer format. Now, when we look at this other one, This one, these are perfect square quadratic trinomials. So same deal. If you could pull out something, go ahead and pull it out, a GCF. But right here, there's nothing to pull out. You can't divide by 2, can't divide by 3. So we're going to jump right in to recognizing that there's a perfect square term in the front and a perfect square term in the back, which means that when I plug it into my factored form answer format, what is the square root of 9n squared? 3n. And what is the square root of 25? 5. And what signs belong in here? All positive, right? Plus, plus. And of course, if you distribute and double check it, it will give you the original perfect square quadratic trinomial. I do apologize. It's 2 lessons in 1. I probably shouldn't have done this, but hey, now you know everything that's on chapter 8. All we got to do tomorrow is practice and then review for the test.